Chapter 4, the Advanced Analysis Optimizer. The optimizer allows the user to fine-tune the design more quickly than the traditional method. The optimizers used to improve the design performances, like optimizing the behavioral mode of the top-down design model generations, improving the designs as per the new specifications. The engines used for the optimization is like MLSQ, Lsq, and discrete value engines. Just open the page as I'm doing over here. Go to optcascode.dsn. In this circuit, which we have previously used, we're gonna modify R1's value as 300, R3 value as display it as a resistance. Do the changes as I'm doing over here. Go in the variables. These are all the variables for this particular circuit. We're gonna change the from an euro, name it as an RES resistance, having initial value 1.1e to 10 raised to 3. Press OK. Display name and value. These are the user variables. Place it in the user variable. New simulation profile. AC sweep. I'm gonna give an AC sweep for logarithmic scale from 1 megahertz to 600 megahertz. Increment as 100 points per decade. They define the profile as an AC profile. Now we're gonna give a DC profile. If the DC profile, give the primary sweep of a voltage source V3. Initial value 0, value less to 0. In the schematic, simulate only the AC portion, evaluate the measurement of that. So the schematic for AC is generated. This is like self-checking the runs. So 1 megahertz to 6. Select the cutoff low pass 3 dB out. cutoff low pass with 3 dB, so we have to place inside the V out. So value coming is 186. Now same for the gain, max V dB out. So max is for the gain and V dB out. So here on the dB scale we got a value of max as a 18.15. 181.5. Now simulate the DC profile. DC profile is for the current from the IQ1 and the power dissipation from the Q1 transistor. So just go on the DC run, which is from add a tray, evaluate the measurement. So it is just an IQ1 and WQ1. In the WQ1, this is the power dissipate out of the Q1. It is 1.5 watt. Second will be the current from the collector current of the Q1, IC Q1C collector current. So 79 microampere, sorry, milliampere. Now in order to set up an optimizer, we will first go to page 1, our main schematic page. Go in the PSpice, advanced analysis, select the optimizer. In the PSpice advanced analysis, so we have to select or import the parameter from the design property. So this will the parameter selection dialog will be open. So we have to select which parameter we wanna deal with that. So this is the error graph on the left, parameters, next run, and the specifications in the down. Select the parameters like C3, R1, R3, R7. So these are the particular values which we're gonna deal with it. So this one is on off component parameter. Minimum value is original is 33, and minimum we are giving at 3.32330. For R7 we give minimum as 24 now, and maximum as 42 now. For R3 we are changing the value to 550 to 11. Okay, now from here, from 30 to 3K, we are going down from 210 to 390. For C3 10.5 to 19.5. So these are the all specifications. Next run, the goal will be to constrain the minimum value over here for the cutoff is 1. So these are the new parameters, and according to that we gonna set up the cutoff low pass frequency 818.5 megahertz, the gain which originally we have 17 dB, power dissipation from Q1. So these are the minimums and that's are the maximums. So maximum power dissipation from the I will be 1 watt, and maximum. So first of all, maximum for the DC current is 50 milliampere, and for DC power is 1 watt. So this is the maximum limit for a Q1 transistor. And the minimum requirement for the gain is 17 dB. So accordingly we will start running the optimizer. We have set the optimizer to run for 20 turns, so it will take a time. And the engine we are using is the Lsq engine. The Lsq stands for the least squared quadratic. So it will square the least square quadratic engine, which is like the gradient based algorithm where the circuit is optimized through a series of like incrementing adjustment. So every incremental adjustment will move closer to the goal and find the fit particular value. So there is like, as you see the difference between original value and error graph. The error graph will try to minimize, come closer to the values. If we go down, so it will increase. If we increased, it will move down. So in this way it comes closer to the particular value where our desired specifications and the components which we have using in the circuit comes to a certain point where we meet the design considerations. So on the down we have the specifications which we needed, which we wanted. See in the right hand side of the specification chart, we have the errors percentage, current, original value. So we will try to minimize the error at 0%. As you can see that we are making more runs. We went closer to the power dissipation for the Q1 and the current dissipation, but still we are struggling with the bandwidth and with the maximum gain. So now his error is coming to in minus 98%. So we will a little bit increase. We have like more 10 runs to go for that. So we have half of our value is reached, quite closer. It will take a time to run your optimizer to the 20 cycles, because it will keep on scrolling down the values. So we have at 11 run of the optimizer, and still we have minus 96% of error at cutoff. So only the cutoff is need to fix. Other things have getting the 000 errors. So means that we are quite closer. Only the thing is to fix the cutoff low of frequency, which is we have set 3 dB. So now the current value The original value we selected for the IQ one was 79. Now it's coming to be 120. So these are the slight changes which we're gonna do in a circuit in order to get the desired specifications. So we are at the 15th Runt, and both of the errors are coming for the gain and for the low pass cutoff. So we have done the optimizations, and now as per the analysis we have to save the file, start the optimizer again, as we are quite closer. I have changed the current from the collector of Q1 as 50 milliampere maximum. Optimization complete. So error is all 0%. These are all the new values, and accordingly these are the new values for our parameters. Save the file. Original was 33. Now once you have completed optimization with the fitting engines, you need actual real world. So we have to make it for a discrete engine. We have to run optimization using a discrete files, because if we have a discrete value, then and only then we can put the particular value in our designings. So click on the discrete, select as I did it. In the discrete table, so give the tolerance like 5% to the registers discrete table. So in between this will give a complete discrete value for our in the current value column as defined in the discrete table assigned for those components. So in the current column you will find, see, in the current column you will find all those particular values which we require. These are the components new value which will be perfectly set for our specification requirement of